So this lesson is all about families of polynomial functions. So by definition, a family of polynomial functions is a set of polynomial functions whose equations have the same degree and whose graph have the same zeros. So our example question here is they give us a polynomial function. It says state two other polynomials that have the same family, are from the same family of functions. So in order to find out if another polynomial is going to be of the same family, we have to know what is the degree and what are the zeros of this function. Well, I can tell easily what the degree of this function is. The degree of this function is 3. But I need to know is the zeros. So how can I find the zeros? Well, zeros are another word for x-intercepts, and those occur when the y is equal to 0, or when the f of x is 0. So 0 is equal to x cubed plus 5x squared minus 4x minus 20. And now I need to solve this equation. And of course, it's a polynomial equation, and it's a long one. It's got 4 terms. I'm going to try grouping. I'm going to see, well, if the 4 would come out, there'd be a 5 there. Oh, there'd be a 5. I think it'll work. So we're going to go with grouping again. I'm going to group those two together like that. Take out the x squared. Here I take out the negative and the 4. It's going to leave me with x plus 5. And yay, it worked out. So in my 2 terms, let me just move the paper up a little bit. Still equal to 0. I can take out an x plus 5 from both, leaving me with x squared minus 4. Oh my goodness, now that one will factor again using the conjugates. Yay, difference of perfect squares. Here we go. X plus 2 and x minus 2. All right, so the zeros, or the x-intercepts, will occur where each one of these at x equals negative 5, x equals negative 2, and x equals positive 2. So the zeros of the function that would have to have the same degree, so another example, g of x, we'll call it, would have to have the same zeros. So we would have to say, well, it's going to have x plus 5, x plus 2, and x minus 2, because it has to have the same zeros, and that would be degree 3. Now what will change the function and make it to be a separate function from this one, but still have the same degree and the same x-intercepts, would be to add a different a value. So I could put, say, a 2 there in front. That would be from the same family of functions. It would have the same number of zeros, the same number of x-intercepts, and it would have the same degree. I could give you another one. There's many, infinitely many. I just keep changing the a value. How about negative 8? That would work. Now it didn't say that I had to have it in expanded form. This one is in expanded form. These ones are in factored form, but I think they're just fine the way they are.